Eduk 802. And today is the normal Saturday, which is 12th of April, 2025. All right, so our target today is to solve some problems on tutorial questions 9 and tutorial questions 10. The tutorial question 9 is on chi-square, while tutorial question 10 is a non-parametric test. I start with tutorial question 9, which in there I have 40 questions. I will see how it will go. Let us start with multiples of 4 for now. By the time we are able to scale through both 9 and 10, we still have some time. We can add more questions to solve. So please, I need decorum, please. No audio disturbance, and let everything be in peace. If you have a question to ask me, you can speak directly to the mic, or you put your question in the chat. All right. To get started, we have question 1 to 40, and we are taking multiples of 4. Then we can start with question number 4. Question number 4 says, a researcher uses a chi-square test and gets a p-value of 0.001. P-value equals to 0.001. This implies dash. A, there is no relationship between variables. B, the variables are significantly related. C, the test is inconclusive. D, the sample size is too small. This question is very simple, but can as well be confusing. There is nothing in this question that lets you know that the chi-square, we said in the class that chi-square has 2 types. We have chi-square test of independence, and we have chi-square test of goodness of fit. In the question, it only says chi-square. There was no indication whether we are talking about chi-square test of independence or chi-square test of goodness of fit. But in the options, you can see actually that the type of chi-square in the question, from the options, you can know that the type of chi-square in the question is chi-square for test of independence. So in chi-square test of independence, if p-value is less than 0.05, okay? If p-value is less than 0.05, you do what? You reject the null hypothesis. And the null hypothesis is there is no significant relationship, or the 2 variables are independent. So in this particular example, where p-value is 0.001, which is far less than 0.005, I can write that as p-value, which is 0.001, is definitely less than 0.05. So we reject the null hypothesis. And when we reject the null hypothesis that says the 2 variables are independent, okay? So that means when you reject that, then the 2 variables must be dependent, must be related. So let's see option 1, there is no relationship. This cannot be the answer. Option B, the variables are significantly related. This is correct, because the null hypothesis is there is, or the 2 variables are what? Are independent. This is the null hypothesis for independent. It's null hypothesis for chi-square test of independence. So if you reject this, it means the 2 variables are dependent, are related. So therefore, the right option there is option B. So the variables are significantly related. Excellent. So we go to question number 8. Which of the following violates an assumption of chi-square testing? Which of the following violates an assumption of what? Chi-square testing. A, mutually exclusive categories. B, frequencies derived from percentages. C, observations are independent. D, sample drawn from the population. Which of the following violates an assumption of what? Chi-square testing. Okay, maybe I should give you the chance to speak here. What will be the answer? You can unmute yourself and speak. Question number 8. Okay, let's pick the option one after the other. Mutually exclusive category. This is correct. We need the categories to be mutually exclusive. Yes or no, true or false. B, frequencies derived from percentages. No, not at all. I think this is the answer. Because we deal with frequencies. We don't deal with percentages. When it comes to what? When it comes to chi-square. Observations are independent. This is correct. And of course, sample must be drawn from the population. So the right option there is option B. We go to the next question, that is question 12. It says, what does a significant chi-square value indicate in a 2x2 table? In a 2x2 contingency table, what does a significant chi-square indicate? This is the same question. I mean, this is similar question to question number 4, but framed in a different way. Okay? An interpretation of a significance.
Excuse me, sir.
Yes, go ahead, please.
This number 8, which is the correct answer? Is it B or C?
I've written it there. Is B. Can you see my board? Is B. Which says that frequency derived from percentages.
Thank you, sir.
It violates the assumption of what? Chi-square that says frequency must be exclusive.
Thank you, sir. Noted. Okay,
now question 12. What does a significant chi-square value indicate? A, mean difference. Never. Chi-square has nothing to do with mean difference. B, a non-random association between variables. C, equal variance across groups, nothing concerning chi-square with variance. D, linear regression exists. Definitely the answer must be B. Non-random association between two or more variables. Two variables, because it's 2x2. Okay, now we go to the next question, and that is question number 16. Question 16 says, which of the following would increase the power of a chi-square? Smaller sample size, lower observed variance, higher expectation frequencies, reducing the number of categories. Which of the following will do what? Will increase the power of a chi-square? Like I mentioned before, in class, we say that chi-square statistics is what? The sum of O minus E squared over what? Over E. Observed frequency, expected frequency. So now look, and the good thing is, the smaller the chi-square, the better for us, isn't it? The smaller the chi-square, the better. Okay? So in this regard, if the expected frequency is high, definitely the chi-square value will add some weight. And in that regard, the power will do what? Will increase. So question 16, definitely, the answer is going to be higher expected frequency. That is option C. Take note of this. Now we go to the next problem. That is question 20. That says, which of these is not a limitation of chi-square test? Which of these is not a limitation of chi-square test? A, it requires a normal distribution. Nothing concerns chi-square with distribution. B, it requires large enough expected frequencies. It cannot determine causality. It is sensitive to small expected what? Values. Which of these is not a limitation of chi-square? The answer must be, it must be A, because chi-square does not require normal distribution of your data set. Remember, normal distribution is peculiar to parametric test. So it requires a normal distribution. It's not a limitation of chi-square test. So the answer is option A. All right, we go to the next question. That is question 24. It says, how many degrees of freedom are in a 4x3 contingency table? 4x3 contingency table. That is row by what? By column. And degree of freedom, we know it is row minus 1 multiplied by column minus 1. How many rows? 4. 4 minus 1 multiplied by 3 minus 1, which is equal to 3 times 2, which is equal to what? 6. So degree of freedom is what? Is 6. Is there any right option? Yes, the option is option B. All right, so we go to the next question. That is question 28. Question 28 says, observed frequency is 25, expected frequency is 20, compute O minus E squared divided by E. What a simple question. Are we there? O is given to be 25. E is given to be 20. Squared divided by E, which is what? Which is 20. 25 minus 20 is 5. 5 squared divided by 20. 25 divided by 20. I hope this is clear. 5 can go. 5 in 25 is 5, and 5 in what? In 20 is what? Is 4. So this is 1.25. So O minus that is question number 32. It says that if the sum of O minus E squared divided by E is 9.8, what is what? What is chi-square value? I want to push this question to you. Okay, can you hear me now? This question number 32, what do you think the answer will be?
The answer is still the same, 9.8.
Excellent. Can you explain why? Why the answer should be 9.8? Why the answer should be 9.8? You need to unmute yourself before you speak.
No, sir.
Yes, please go ahead.
Yes, sir. The reason is the formula for chi-square is observed value minus expected value all over expected value. That is square all over expected value. That is the formula.
I'm just writing the formula on the board. So this is the formula that says the sum of this quantity. So you see this sigma means sum of, and the quantity is given like this. So definitely this is just the chi-square formula written in words. So if this sum is equal to 9.8, definitely the chi-square statistic must be 9.8. Thank you. Look at how simple this question is. In the exam, you will be troubled if you cannot just see this connection. Let's go to the next one. That is question 36. Thank you very much for the response. Question 36 says, if degree of freedom, df, is 3, and then alpha is equals to 0.05, then the critical value is what? The critical value is what? Is what? So this is just testing your knowledge on reading the table for chi-square. The critical chi-square value, that must be indicated. Okay, so we need to check at the chi-square value table. I think I attached it here for simplicity. So to check this, we look at the critical value of 0.005. Look at it here. From the end, 1, 2, 3. Okay, good, I can do this one. Look at it. That's why we have the chi-square value for 0.05. Then we look down at degree of freedom of 3. Degree of freedom of what? Of 3. That is the point. Degree of freedom of 3 for alpha value of 0.05. So I can read from there, critical value to be equals to 7.815. This is what I got. So let's go back to our question whether that option is there or not. Question 36. Oh, 7.81. So we can pick that. Even though so 2 decimal places is 82, but that is the closest answer in the option. So the option is what? The right option is option B. I hope this is clear. The last question for the chi-square problems, it says, given the chi-square value of 5.1 and degree of freedom of what? Of 12, alpha is 0.05. Is this statistically significant? Is this what? Statistically significant. These are our chi-square value. For we to know whether it's statistically significant or not, we need the chi-square critical value. You get it now? Because we don't have the p-value with us. Okay? So we need the chi-square critical value. So and to do that, we need to read the table again. Look at 0.05, all right? Oh, that's good. It can be better like this. So this is 0.05. All right? So we need the degree of freedom to be 2. If you look here, degree of freedom, GF2 is the second row. You trace it down to 0.05. Look at it here. So the answer is what?
5.99.
Excellent. So it's 5 points. Critical value equals 5.991. So for you to make a decision, your chi-square value must be greater than critical value. Remember that before you can reject. Greater than or equal to. If it is less than, you fail to reject. In our example now, chi-square value of 5.1, chi-square value of 5.1 is less than the critical value. It's greater than the critical value, because the critical value is 5.991. So we are going to fail to reject. We are going to fail to do what? To reject. So we fail to reject. Well, is this statistically significant? The answer is no, because we fail to reject. Are you okay? So the answer is what? Is no. Perfect. So here comes the end of the questions for chi-square tutorial. Now we move straight to non-parametric test. That is tutorial set 10. Tutorial
Excuse me,
set.
sir.
Yes,
Excuse me,
why?
sir. Sir, you mean when you fail to reject, then it's significant?
It is not significant. It is not statistically significant.
Okay. Okay, not statistically significant. Okay, yes, sir. Okay.
The question
Excuse me,
says,
sir.
wait, the question says, is this statistically significant? The answer is no, because we failed to reject the null hypothesis. It is only significant when we reject the null hypothesis. Yes,
Thank you,
go
sir.
ahead. Someone don't ask a question, go ahead.
Some of the options here, they appear
Mhm.
to us like question 36, question 35, 39, 27, and question 6. So we don't know the
Yes.
option that we're going to select.
Okay, which one is correct?
What we are saying, the options
No,
appear to us correct answer.
the repeated option, is that the correct answer?
Yes, sir.
Yes,
And
sir.
then you pick any of them.
Okay, sir.
Yes, thank you.
Okay.
And that's a good observation anyways. So we go to the next problem. That is tutorial set 10. Again, we take multiples of 4. So we start with question number 4. Question 4 says, the Mann-Whitney U-test statistic is calculated based on mean values, rank sum, variance ratios, frequency tables. This must be what? B.
Rank sum.
Rank sum. Thank you. We go to problem 8. It says, in the Wilcoxon test, by the way, Mann-Whitney U-test is the equivalent of t-test independence, right? Independent sample t-test. The equivalent is what? Mann-Whitney. And Wilcoxon sign rank test is an equivalent to independent sample t-test or peer sample t-test. Okay, this guy now says in the Wilcoxon test, if all differences are positive, if all differences are what? Are positive, what is the value of the test statistic? What is the value of the what? Test statistic. This question is amazingly simple, okay? And at the same time can be confusing. Remember in the Wilcoxon, where we say W is the minimum of positive and then what? Negative, okay? Because it's sign rank. So the minimum now, if the differences are all positive, right? So that means you'll be dealing with only positive difference, the positive weights, the positive statistic. And being positive, it means it is greater than what? Than 0. That's the meaning of positive. It means it is greater than what? Than 0. So the minimum you can get, W, it must definitely be the minimum of W plus and then 0, which is always what? 0. So the Wilcoxon statistic will be 0 if all differences are positive. So the right answer there is option B. Do you get this? Perfect. We go to the next question. That is question 12. And it says, what kind of data is appropriate for Kruskal-Wallis test? Kruskal-Wallis, you must have more than 2 groups because it is equivalent to what? ANOVA as a parametric test. So the non-parametric equivalent of ANOVA is what? Kruskal-Wallis. They now say here, what kind of data do you need? A, normally distributed interval data. This is no, isn't it? Because you don't need normality for a non-parametric test. B, binary. So I gave you a task the last time before I left. That is on question 20. What does a significant Friedman ANOVA indicate? And the answer is that it indicates at least one condition differs significantly. So the right option is option C. We go to the next question. That is question 24. It says, in which situation would a non-parametric test not be appropriate? In which situation would a non-parametric test not be appropriate? A, when the sample is large and normally distributed. B, when dealing with Likert scale data. C, when data contains outliers. D, when using ordinal measures. The right answer is option A. You know why? When the sample is large and normally distributed, you don't need non-parametric at all. In fact, some non-parametric tests, as soon as the sample is above 20, then it becomes a problem. So non-parametric tests are usually for small sample size. So when the sample is large and it is normal, in fact, as soon as the sample is large, you will see that it is tending towards normality. When dealing with Likert scale data, yes, we use parametric tests here because we'll be dealing with ordinal data. Or when data is contains outliers, this is a good situation when we can use non-parametric tests because we are dealing with ranks, not with the actual data. So the outliers may not affect it, unlike in parametric tests, where the outliers will skew the mean and even skew the standard deviation. When using ordinal measures, definitely yes. So the time that is now appropriate to use non-parametric test is when the sample is large and normally distributed. The next question, question 28. It says, which type of data is not suitable for non-parametric tests? It's also similar to 24. A, rank data. B, nominal data. C, ordinal data. D, none of the above, none of the options. When the data is rank, definitely we use what? We use non-parametric test. What about when it is nominal? Do we use non-parametric test for nominal data? Maybe one part is nominal, we can use it. Like we have yes or no questions. So we can use non-parametric test. Can we? The answer is no. Because non-parametric tests, nominal data, analysis of nominal data is done using chi-square. That's why we'll be analyzing frequencies. You get it now? So non-parametric tests, as we know it from here, they are Mann-Whitney, Wilcoxon, Kruskal-Wallis, and Friedman. So these non-parametric tests, they are used for rank data. So the right option there is option B. We don't use it for nominal data. We use it for ordinal, yes, but not for nominal. So that option here is option B. Take note. Question 32 is the next question. It says, in a Wilcoxon test, the sum of positive ranks is 22, and the sum of negative ranks is 3. W plus equals to 22. W minus equals to 3. What is the test statistic? What is W? W is the minimum of W plus, W minus. So what is the minimum? The minimum number between 3 and 22, or 22 and 3. The answer is what? Is 3. So the test statistic is what? Is 3. Oh, okay, option is there. So the right option is option B. Are you okay? So we go to the next question, yes. And that is question number 36. Question 36 says, Friedman test with n equals 6 subjects and k equals 3 conditions yields a test statistics of 7.8. Friedman test. We didn't do calculation on this. N number of subjects is what? Is 6. But k, that is number of groups, is what? Is 3.
Excuse me, sir.
Go ahead.
Excuse me, sir. You skipped question 34 and 35, sir.
No, we are dealing with multiples of 4. So after
Okay.
32, the next multiple of 4 is what? Is 36. I'm not solving all the questions. All right. So we have our Friedman statistic to be 7.8. And our N, the number of subjects in each group, is a 6. And the number of groups, we have 3 groups. Then this now say, chi-square critical value at degree of freedom 2 is 5.99. Chi-square critical value, remember, we are dealing with what? Friedman. But they are talking about chi-square critical value to be 5.99. And this is alpha, this is for alpha equals to 0.05. What is the conclusion? In class, I think we don't cover this aspect. Let me tell you something. You see, for Friedman and over, we don't use, it does not, let me say, it has a table. It has a distribution table. However, we use chi-square distribution table for it, especially when the sample size is less than 20 in each group. The chi-square distribution table, it works perfectly well for Friedman and over. So instead of looking for any table for Friedman, just use chi-square distribution table. And the degree of freedom for Friedman is number of groups minus 1. How many groups do you have? Just subtract 1 from it. In this case, the number of groups is given to be 3. So degree of freedom is going to be what? Is going to be 2. So in this question, you are now given the chi-square critical value to be 5.99 when the degree of freedom is 2. So this is your critical value, which is for chi-square and at the same time for Friedman. So our statistic is 7.8 and critical value is 5.9. That means the statistic 7.8, that is statistic, H statistic, is greater than 5.9 critical value, isn't it? 7.8 is greater than what? Critical value. The conclusion is to reject the null hypothesis. The conclusion is to do what? I told you in class, please don't mistake this. You see, for Kruskal-Wallis and then Friedman and over, you interpret the two of them the way you interpret non-parametric test. I mean, in terms of rejection using critical value. Okay, but if it is Wilcoxon and Mann-Whitney, it is the opposite. It is what? It's the opposite. Take note of that. If this one is Wilcoxon now, we are going to fail to reject. It must be less than critical value. Take note of this. The next question, which I think is the last question, that is question 40. Question 40 says, Kruskal-Wallis test yields H equals to 4.35, H equals to 4.35. Okay? With degree of freedom of 2. I think I should mention this. You see, for chi-square, degree of freedom of 2, 5.99. Maybe you should memorize this. Okay, it's a good reference that we usually use, especially when we talk about Friedman and over, because we deal with 3 groups most of the time in ANOVA. So maybe you can memorize this. 5.99, it can be used to, you don't know, you never can know. But in any case, that's just by the way. So Kruskal-Wallis is H to be 4.35 and degree of freedom of 2. Can you see? Critical value at alpha equals to 0.05 is still 5.99. Critical value equals to what? 5.99. So what is the conclusion? And that's the next question. What is the decision? H value 4.35 is less than, isn't it? 5.99, which is the critical value. Okay? So when the statistic is less than the critical value, you do what? You fail to reject. You fail to reject. So the conclusion is what? Fail to reject. There is no statistical difference. There is no significant statistical difference, okay, in your subjects. So this is what you have. And I think this is a convenient place to look at it and see what again can we talk about. Now, do you have additional questions? Maybe you can take the questions in the next 7 minutes before we close. Do you have any special question you think is difficult you want me to solve from tutorial 9 and tutorial 10? Now the floor is open.
Hello, doctor.
Please go ahead.
Sir, it's not about this tutorial, but I just want to find out if you can help us send the link to your Google Drive.
The link to the Google Drive again?
Yeah, we are very sorry.
Ask some of the class members, they have it.
Okay, sir.
Yes, the class members should have it. Is Onai in class? Onai should have it.
Yes, sir. Yes, I have it. I will send it.
Yes. So thank you very much.
Thank you.
Any other comments? Any other comment, questions? See, this time is to solve questions.
Sir, please, number 39.
Of tutorial 9 or 10?
10, sir.
Tutorial 10, thank you. Question number 39. It says, if U equals to 0 in Mann-Whitney U-test. Question 39. Mann-Whitney U-test, U is what? Is 0. What does this indicate? Tied ranks, equal distribution. All values in one group are lower than the other. Test is invalid. The answer is C. All values in one group are are lower than the other. This is when you have U to be what? U to be 0. Okay? It means the sum of rank minus that quantity is equal to 0. So take note of that. So when you have that, it means all values in one group are lower than the other. The next question. Any other question?
No. Yes, sir. Question 37.
Of tutorial 9 or 10?
10, sir.
Okay. Let's
Thank
see.
you.
37 says, given group A ranks to be this, group B ranks to be this, group C ranks to be this, compute RC. This is the simplest question. Question 37. Look at it. Group A ranks to be 1, 2, 3. Group B ranks to be 4.5, 6, and 7. And group C ranks to be 4.5, 8, and 9. So RC is the sum of ranks in that group. 4.5 plus 8 plus 9. Do you see this? 4.5 plus 8 plus 9, 17. 4.5 plus 17, 21.5. So RC is 21.5, which is option B. Are you okay? These are the simple questions I will ask you.
Excuse me, sir.
35.
Question 35. See this tutorial?
Yeah.
Okay.
Tutorial 10.
Question 35 says, if all differences in Wilcoxon test are 0, what is the appropriate conclusion? Remember, we need the Wilcoxon test to have what? To have either positive or negative, right? Remember, W in Wilcoxon is the minimum of what? W plus, then what? W minus. So if all differences are now 0, what will you do? Test is invalid. Test cannot compute the test. Always reject 0, always accept 0. The answer is test is invalid, doesn't work. Okay, the test is what? Is invalid. And when you check, 1 minute, please. Look, when you check the
35.
You see, when you check the table, you will find that at alpha equals to 0.05, there is no value there that is less than what? Less than 0 or equal to 0. So take note, the test is what? Invalid. The next question.
So I want more clarification regarding these things of failing to reject and rejecting.
Based on what? Based on p-value or critical value?
Yes. Yes, sir.
Based on what?
P-value.
No, p-value is the simplest. It's straightforward. If p is less than or equal to 0.05, you reject. And if p is greater than 0.05, you fail to
reject.
Reject. That is all. Very simple. Yes. Question 23.
Hello, sir.
Yes.
33. MS 10. SMO 10.
33 or 23?
33.
Okay. Question 33. It says what? If Kruskal-Wallis test with R1 equals to 12, R2 equals to 18, R3 equals to 30, and a group size of 3, what is what? What is H? In a Kruskal-Wallis test, H is given by this formula. Please, you are the one to complete this. H is given by n into n plus 1, okay? Number of subjects. The sum, remind me, who remembers? Ri squared over ni minus 3 into n plus 1. I think this is the formula. Please, you can confirm. You can confirm the formula. So you are given R1 to be equals to 12, R2 to be equals to 18, R3 to be equals to 30. Then what again? Sample size n equals to what? Equals to 3. Just make your substitution. H equals to 12, okay, divided by n into n minus 1, 3n plus 1, 3 into 3 plus 1. This is it. Multiply by the sum of the square of the ranks, that is R1, 12 squared. You see this? Divided by the sample size, 3, plus R2, 18 squared, divided by 3, plus R3, 30 squared, divided by 3. So this is what you have. Minus 3 into n plus 1. That is 3 plus 1. As simple as just do the arithmetic. 12 divided by 3 times 4. You know, this 3 plus 1 is 4. That's another what? Another 12. You see this now? Okay? Into bracket 144 divided by 3 plus 18 squared. What is 18 squared? Tell me, what is 18 times 18? 18 squared. 18 times 18 is 324 divided by what? 3. Okay? Plus 30 squared. 30 times 30. You get what? 900 divided by 3. And so this is, minus is there. Minus 3 plus 1, 4. 3 times 4 is what? Is 12. Just put it there. Right. This way. So minus what? Minus 12. As simple as that. 12 divided by 12 is 1. Okay? 144 divided by 3. 144 divided by 3. That is 48. Plus 324 divided by 3. That is 108. Plus 900 divided by 3. That is 300. Minus what? Minus 12. So what do you get? 48 plus 108 plus 300 equals to
minus 12.
456 minus what? Minus 12. Are we sure? It's like something is missing, maybe in the formula. So 456 minus 12, that gives 444. Please confirm the formula. Maybe something is missing when I was writing the formula. I don't think the answer should be as high as it's too high for each statistic, but you can confirm. The formula I wrote is 12 over n into n plus 1. Okay? Okay. So please confirm the formula, and then you find out that the answer is either this or different from this. This is a H statistic, but it's all about arithmetic and nothing more. Are we okay?
Okay. Yes, sir. Please, I want to ask. Can you please shed more light on number 22 of SMO9?
Number 22 of SMO9. Okay. Given observe, I think we solved this problem. We solved a similar problem just in this tutorial. So you just need to complete simple calculation. Question 29 or 22?
22, sir.
22, okay. 22. So you have O is given to be 40. Okay. E is given to be 30. Then you have to find O minus E squared divided by what? E. Very simple. What is O? 40 minus E, 30. Square it divided by E, 30. 40 minus 30, 10. 10 squared divided by 30. 100 divided by 30. 10 divided by 3. 3.33 and so on. So the answer is 3.333. The answer is C.
Okay. Which one is it? 22.
Hello, sir. I have one question, please.
Please go ahead.
SMO
10 question 31.
SM10 question 31.
Yes, sir.
Okay. Question 31 says that you are given RA to be 15, NA to be 4, NB to be 4. Calculate UA. UA by the formula is NA, NB, isn't it? Plus NA into NA plus 1, all right? Divided by 2 minus RA, isn't it? So NA is given to be 4 times NB is 4 plus 4 into 4 plus 1 divided by 2 minus RA. What is RA? RA is given to be 15. 16 plus 4 times 5, 20 divided by 2 minus 15. 16 plus 10 minus 15, which is what? 26 minus what? 15, which is equals to what? 11. So the right option is option A, isn't it?
Sir, please, where did the 16 come from? Where did the 16 come from?
4 times 4.
Okay. 4 times 4.
Are we okay? Yeah. Attending is a good place for us to stop.
No, sir.
Okay, what is your question? Go ahead. What is your question?
Question 38, sir. 38.
Question what?
sir.
I think I've solved 38 now, didn't I? Okay, no, I've not solved 38. Let's see question 38.
Question 7, SMO 10.
Let's solve 38 first, madam. Okay. In Wilcoxon test, D values, they are this. Compute WH based on sign rank. WH is just the sum of positive sign. Okay, these positive ranks. So the positive ranks here, they are 2 plus 5. 5 is positive. Plus 10 plus 10. Okay? Oh, wait a minute. These are the differences, not the ranks. Take note. These are the differences, not the what? Not the rank. You need to rank them first. You need to rank them. This is a very important question. You need to rank them. Look, you have 2 difference, okay? Minus 2. Then, okay, maybe I should do it this way. Instead of making it horizontal, let's make it vertical. So we have 2 minus 2, 5, 10, 10. These are differences. These are D. Okay? You need to rank them. What are the ranks? These are supposed to be naturally, but these 2 and minus 2, they are the same. Only the sign. And we don't care about the sign. Naturally, this is supposed to be 1 and then 2. Okay? But because they are the same number, so you're going to find the average of 1 and 2, which is 1.5. So the first rank is 1.5. The second rank is what? 1.5. And this will be 3. You see it now. Then this naturally is supposed to be 4 and 5. They are the same number. So we find the average. So this is going to be 4.5, and then it's going to be what? 4.5. So only this one is a negative rank. You remember, because it's coming from a negative difference. So the sum of positive ranks will now be 1.5 plus 3 plus 4.5 plus 4.5. Okay? And this will give you 1.5 plus 3. That is 4.5. Plus 4.5 plus what? 4.5. So what do you get? 4.5 plus 1.5 is 9. Plus another 4.5. This is equals to what? 13.5. Are we okay?
Yes, sir. Thank you, sir.
So the answer is what? Is C. That is your W plus.
Thank you very much, sir.
Somebody said question 7.
Thank you.
Somebody said question 7. Which of the following best describe the null hypothesis in Wilcoxon's
Number 7, SMO 10.
Yeah, that's what I'm reading. Which of the following best describes the null hypothesis in the Wilcoxon sign rank test? The means, nothing like means, okay, in sign rank test. But the median difference between pairs is 0. The variance, so I will go for the what? The median. You know? Wilcoxon and Whitney, they either deal with the median or the ranks. So the option is what? Is B. Take note of that. Okay, I think I can stop now, yes?
Thank you very much, Doctor.
So thank you very much. So this is a good place for us to stop today.